Right, if you remember looking at this graphic before, when we were talking about infrared remote control theory, might look familiar to you. We talked about what a carrier wave was and the process of combining a carrier wave with whatever code is that we're trying to send. The combination of those two would result in this, which is a modulated waveform. It's a combination of both of the two previous waveforms. So looking at this and what it represents, well, think of it this way. It represents the LED, the infrared LED turning on and turning off and on and off, in doing that 38,000 times every 1 second. So think of it as this is the time the LED's on and then off and on and off and on and off. And it repeats that, but it does it so fast, 38,000 times a second. That's key. So it's looking for that rate of the light turning on and off. If it doesn't see it turning on and off at 38,000 times a second, then it doesn't even acknowledge it. It has to see an infrared light turning on and off at that rate in order for it to even be recognized. Okay. So then the second part of that is the code. And remember, we talked about this being compared to like Morse code, where we'd send longs and shorts. And so we'd have different codes for each of the different things that we'd want maybe the TV to do, like volume up or volume down. So in this example here, if this were the code, we'd be looking to see the code for this amount of time. And then during this time, we'd see absolutely nothing, no light at all. We would see light. Here we would see no light, and here we would see light. But what you got to keep in mind is during the times that we see the light, what we're talking about seeing during this amount of time is the infrared LED, which is turning on and off at 38,000 times per second. It has to, one, be an infrared light, and two, it has to be an infrared light turning on and off 38,000 times per second. So if it were turning on and off at any different rate, it wouldn't see it. It wouldn't acknowledge it. It has to be that. And again, key is that it has to be the infrared LED. Okay, so that's this. So now let's take a look here at a remote control, and I'm going to shine the light on the paper. Remember, our camera can see this. Our eyes can't. So first off here, whatever the receiver is, so the TV, it would have to first be an infrared light, like you see here. If it were any other colored light, like the red LED that we put in there, wouldn't work because it's not the right color. It has to be infrared, a particular infrared light range, or the spectrum of light that it gives off falls in the infrared range. The red LED, that has a different wavelength, and it wouldn't even see that either. So it has to see the right wavelength of light, which is the infrared region. Okay. And then in addition to that, remember, then we have the code. And you can even kind of see that here. See how you kind of see the light pulsating a little bit? Maybe that helps put it all together. So one, we're seeing infrared light. Two, we're seeing periods of light and periods of no light. And three, during the time that we actually see light, we're actually seeing the light, which is turning on and off 38,000 times per second. But during those short little tiny periods of darkness, the LED is actually off. But the time that it's actually on and you do see it, it is, yes, on. Well, kind of on, because it's actually turning on and off 38,000 times per second. We just perceive it as seeing it there. So anyway, I hope that brings it together. Then now let's talk about the jammer. So the remote jammer, if you remember, we have this set up so that it's just basically turning on and off the LED 38,000 times per second continuously. Right? So that was key. It has to be at that frequency, but it is also an infrared LED. Okay, so if it were a red LED that we had in there, any other color, the receiver wouldn't even recognize that color. It only could see this particular color for one, the infrared wavelength range, and two, it'll only understand if it's turning on and off 38,000 times per second when it is operating. Okay, so let's combine them. Here we have our infrared jammer. And so now the whole point of the jammer is basically to fill in the gaps over the periods of darkness here, and I'm filling it in with the carrier wave, which is nothing more than the light turning on and off continuously. So it's filling in the gaps. And yeah, it does acknowledge what the remote jammer is actually sending out because it's an infrared LED and it's turning on and off 38,000 times per second. So this is filling in the blanks. So if I were to go back to my picture here, really what's happening, this would be without the remote jammer on. So this is just the remote control, the way that we saw it operating. But when we add the remote jammer to it, it basically, this is what the remote jammer is just doing, turning on and off an LED. It more or less fills in the gap right here with these waveforms.